Now I'm going to tell you about the algorithm that hashtables use in .NET to determine what bucket an element goes in, because that'll help us understand the requirements on GetHashCode. But bear in mind this is a .NET implementation detail. It's probably not going to change, but that's not guaranteed, so you shouldn't rely on it. Let's say you have a value x of some type, and it needs to go into a hash table based collection. In .NET 4.5, the way the hash table decides what bucket an element goes in is this. It calls GetHashCode on the item. That returns the hash code, a 32-bit integer which represents the hash of the value. The hash table then does something like this. It divides the hash code by the number of buckets in the hash table and takes the remainder. Remember, in C# that's done using the modulo operator, which is represented by a %sign. And then the answer to that calculation will be the index of the bucket that the item will go in. I'll give you an example to show you how this works. Let's say the values you want to put in the buckets are strings. Imagine, say, it's a dictionary keyed by strings. A dictionary of string and T. We don't care what type T is, because we're thinking only about the keys here. And this time, for the sake of this example, we'll assume there are 5 buckets in the dictionary's internal hash table, with indexes 0 to 4. Again, this is a very small number, just to keep the diagram simple. The actual number of buckets is controlled by the dictionary. It's not something you would normally worry about when you use dictionaries. So let's say you wish to add something that has a key of apple in lowercase to the dictionary. That requires adding apple to the hash table. On my system, the hash code of lowercase apple is this rather unpleasant number, slightly more than 1.6 billion. But when you divide this number by the number of buckets, 5 in this case, and take the remainder, you get 4. So that means apple should go in bucket number 4, the last bucket. Now let's add something that has the key pair to the dictionary, which means adding pair to the hash table. On my computer, the hash code of pair is another rather nasty number, this time around -422 million. But what matters again is not the actual number, but what you get when you divide by the number of buckets and take the remainder. In this case 0, so pair will go in the first bucket. And let's say that with the same dictionary, later on the code evaluates this expression, mydict square brackets apple, which asks for the value with the key apple. The dictionary will simply run through the same procedure, apple.getHashCode %number of buckets, which obviously will give the same answer as before, 4. So it knows that if this item is in the hash table, then it will be in the last bucket, so it can just search through the elements in that bucket to see if it's there. And in this case, yes it is. And remember, the whole point of this procedure is to make sure you don't have to search many elements to find the one you want. And that's what gives dictionaries and other hash table based collections their high performance.